Hey, welcome back to Electrically Constructed. I'm Master Electrician Seth Eckel, and this is our second video of our Raceway calculation series. In our last video, we covered the basics of Raceway calculations, and in this video, we are going to apply some of those basic rules. But first, we're going to figure out how to size our conductors and get our conductor volume and apply it to which Raceway it's going to best fit. All right, so get out your code book, the 2026 NEC, and also get out highlighter, calculator, pencil, and some scratch paper, and let's get started. All right, guys, let's get our code books open to chapter 9 tables. And in this video, I want to teach how to actually perform Raceway fill calculations. Before I show you the easy way, where if you have all the same conductor sizes, you can go to a table and just get your answer right away. But I want to walk through and actually have you guys understand how to do the calculation in the full process of sizing your conductors for your Raceway fill. So the tables we're going to focus on today are going to be table 1. We have to understand that from the first video, the percent fill. But the other tables we're going to focus on is going to be tables 4, 5, and 5A. All right, so 4 is going to be our Raceway tables. So these are the dimensions and percent area of conduit and tubing. All right, I already have mine all highlighted. If you guys want to highlight yours, I highly recommend that. I like to highlight what the Raceway type is. I like to highlight my main columns that I use. So I usually use the over 2 wires, 40%. I use the 60% fill column quite a bit. The 1 wire and the 2 wire, those I don't use as much, but it's a nice reference to have here. Comes in handy when you do have 1 or 2 wires. And then I got my 100% fill over here. Today we are focusing on the 40% fill column. All right, and then I just want you guys to see this, how you have every single type of Raceway for metal tubing and or not metal tubing, just conduit or tubing. And I got the first one is EMT, next one is ENT, then flexible metal conduit, and so on. Goes through a few pages. At the top I usually write table 4 continuous Raceway. All right, and then keeps going. Table 4, you see a flexible metal conduit in here, you have rigid metal conduit, PVC, schedule 40, schedule 80. This one right here, the schedule 41, is kind of one I wanted to point out because it has 2 types of Raceways in there. It has schedule 40 and HDPE conduit. So these 2 types of Raceway are sharing the same chart here. All right, and before we keep going, let's see here. I want to point out too the trade size. So you have all your different trade sizes. 3/8, ½ inch, 3/4, 1 inch. This one goes all the way to 6 inch. Some of them don't have quite as much. So like this one here for the type A PVC, it stops at 4 inches. Let's jump into table 5. Table 5 is dimensions of insulated conductor and fixture wires. So the important columns that I highlight in table 5 is the approximate area in square inches, and I also highlight type. I don't highlight every single type of wire until I need it. The type I most commonly use is the THHN, so that's the one I got highlighted already. And then there's the size as well, so size of the wire. You can see here, this column, we have THHN, THWN, THWN-2, all these different types of wires in the same, they have the same square inch for their approximate area. So they all get categorized together. So they got 14 gauge and it goes all the way up to 1000 kc mil. So that is the one we're probably going to use today. Is we're going to focus on sizing our Raceway using THHN cable. All right, and let's see, we want to go to table 5A as well. So table 5A, it is another table that we have to use. It's a different type of cable though, compact, copper, and aluminum. We also have bare conductor in here as well. But you have to use this table if you have compact copper and aluminum wire or bare conductor. And these are the types of wires that are types of conductors that would have that RHH, THW, THHW, THHN, XHHW, and then they have their approximate area in square inches as well with the different sizes. Okay, so now that we understand the tables and the table that we're using for today to get our calculations, let's start walking through some examples. So I'm going to go back to, or actually I'm going to go hold this up. All right, and go step by step here. So step 1, we want to identify the raceway type that we're going to be using. So in this one, we are going to be using EMT. All right, we don't know what size yet, but we're going to be using EMT. Okay. Step 2, identify the conductor and insulation that we're going to be using. So in this example, we're using THHN. So we'll go to table 5, we'll find THHN. Here we go. Step 3, we want to find the conductor area. All right, so in this example, we're going to use number 12 gauge. So let's go look at our table here. Look for number 12. We got 12 gauge wire right here, and that is 0.0133 cubic inches. All right. This is where you find the approximate area of one insulated conductor. All right. Now, step 4, multiply by the number of conductors that we have. So let's go back to our table. Okay. In this example, we are going to use 8 12 gauge conductors. So what we'd have to do here is going to take 8 times 0.0133. So pretty simple. 8 12 gauge conductors of THHN is 0.0133 times 8 equals 0.1064 cubic inches. All right, or square inches, I'm sorry. Let's see here. Now we're gonna take this answer, we're gonna go back to table 4, and we're going to look for what size conduit can we use. What is the smallest size conduit that we can use? So let's see. We're at step 4, step 5, find the raceway of the area. All right. Step 6, use the correct fill percentage. So what they're saying there, make sure we have 8, so we're over 2 wires, 40% fill. So we're going to use this column right here. And step 7, pick the smallest raceway that meets the required area. So we got 0.1064 square inches, and the smallest area, or the smallest trade size pipe that we can use for this is a 1/2 inch, because 0.122 is larger than 0.1064. So the answer here is a 1/2 inch raceway. That is the small size though. We could use any other size we want. This first example is probably the easier example. That's all the wires are the same size. That's not always going to be the case when you're pulling wires in a raceway, but I just wanted to get an easy one out of the way so it makes sense to you guys how this works. And just go step by step here. You guys can use this for yourselves later on. Step 1, identify the raceway type. Step 2, identify the conductor and insulation. Step 3, find the conductor area. And right away I want to point out these tables aren't don't use these tables, use your code book tables, because this table here isn't telling you the type of wire, so we don't know what type of wire this is. So don't go off that table, don't think that table works for you. Step 4, multiply by the number of conductors. So you get your wire size, multiply by how many you're going to fit in there. Step 5, find the raceway area. Again, this table is not telling you the type of raceway, so you can't use this. But use table 4 to find the available area inside the raceway for the conductor fill calculation. Step 6, use the correct fill percentage from the table 1 that we looked at in the first video. Step 7, pick the smallest raceway that meets the required area. Alright, so again, step 7 is more like a exam question type of way of doing it, but the smallest raceway isn't the raceway you have to use. You can use a larger raceway if you wanted to. You know, you do your best practice and what works for you, you're going to figure that out for yourself. So, but when you're doing like a test question or something, you're probably going to pick the smallest raceway because that's how test questions are usually written up. Those are the steps for doing this. And again, that's going to be the easiest calculation. And then in the next video, I'm going to show you tables where you can actually go to and get those answers right away without having to do the calculation if all the conductors are the same size. But I wanted to show you the process, and that was an easy example. But let's go back to our code book, and in chapter 9, tables, table 6 tells us we have to use that process when we have more than if we have multiple sized conductors in the same raceway. So table 6 says, for combinations of conductors in different sizes, use actual dimensions or table 5 and table 5a for dimensions of conductors, in table 4 for the conduit or tubing dimensions. So that is basically what we just did, but we just used one size conductor instead of multiple size conductors. Let's go to another example. So this is example 2. All right, we have 3 10-gauge THHN sets with 3 14-gauge THHN pairs plus 1 green ground, 10-gauge green ground. All right, so 1, 2, 3, 4, 5, 6, 7 10-gauge conductors, 1, 2, 3, 4, 5, 6 14-gauge conductors. So let's go to our code book and let's start with our THHN. So we know that we are using 10-gauge THHN. I'm going to pull up my little multipliers here. So the first thing we have to do, we know that we had 7 10-gauge THHN. So we go to the approximate area, square inches, 10 gauge, 0.0211. So we get that calculated out. 7 times 0.0211 equals 0.1477. All right, and then the second calculation, we're going to have to figure out what the 14 gauge, we had 6 of those, so we're going to multiply that by 0.0097, and that's going to give us 0.0582. All right, and then we got to add these two together. .1477 plus 0.0582 equals 0.2059. So that's how much space we're taking up with our conductors. So now we have to go back to our EMT because that's the raceway we've chosen. Got to go back to table 4. We got 0.2059. The smallest raceway that we can use. We gotta make sure we go to the right column. Over 2 wires, 40% fill. Smallest table we can use, or smallest EMT conduit we can use, 3/4 inch. because 3/4 inch is 0.213, which is larger than 0.20. So let's switch it. Let's switch the raceway we're using. Okay, we got E&T right here. What is the smallest raceway that we could use if we were running these wires in E&T? Well, if you look right here, you got your trade sizes, over 2 wires, 40% fill, square inches. Smallest raceway we could run this in is 0.333, a 1-inch raceway. Is just too much already for the 3/4 inch raceway. Just 3/4 inch raceway is 0.203, which is smaller than 0.205. So you'd have to move up to the 1 inch if you're running E&T. All right, so the next thing I want to do is I want to leave you guys with a challenge question. Okay, the challenge question is we have 9 12-gauge THHN conductors plus 8 14-gauge THHN conductors. We're going to run them all through schedule 40 PVC raceway. I want you guys to tell me what the smallest size is. All right, leave your answer in the comments, and I will answer this one at the beginning of my next video. So you guys can use the step-by-step directions that I have in the video. Go back and review that and try to answer this and put it in comments. So what I want you guys to take away from this video is that raceway fill is an area calculation. You're taking the square inches of the conductors, you're adding them up and getting your answer to see what conduit it will fit in. All right, if you have the same size wires, then it's a much easier calculation. In fact, there's tables for that, and we're going to go over those tables in the next video. But if it's multiple, or if it's different size conductors in the same raceway, then you must use the steps that we went through today. All right, that's all I got for you in this one. Stay sharp, never stop learning. God bless. Can't wait to see you in the next video.